Moving on to question 3 now, we have a question here dealing with discrete random variables. So what we've got here is we've got a bias spinner which can land the numbers 1 through to 5, and we've got these following probabilities. So it tells us it's spun 80 times and the mean of the numbers it lands on will be calculated. We've got to find an estimate of the probability that its mean will be greater than 3.25. So we've got to find probability that x is greater than 3.25. But how do we do this? Well, the first thing we could do is we could work out the expected value here. Okay, so e of x, well, how do we work out e of x for discrete random variables? Well, e of x, that's going to be the sum of these multiplied together, okay? So 1 times 0.3 plus 2 times 0.1 plus 3 times 0.2 and so on, okay? So it's going to be the summation of these. So if we do that, we do it in a bracket, it's going to be 1 times 0.3, so I'll just write 0.3 plus 2 times 0.1 plus 3 times 0.2 4 times 0.1 and finally 5 times 0.3. Okay, now if you simplify all this, work out this calculation, what you'll get is that e of x, which is equal to the mean, is equal to 3. Okay, so we get straight away that the mean is equal to 3. Now let's work out the variance, because if we can work out a value for the mean, we can work out a value for the variance of this distribution here. Well, we might be able to use some statistical information that we already know, maybe the Central Limit Theorem, to get a distribution that we can then use. So let's work out the variance here. So e of x squared. Well, how do we do this? Very similar. What you've got here is the number on the spinner, so we're going to square this value and then times it by its corresponding probability. So this will be 1 squared times 0.3, so 0.3 plus 2 squared times 0.1 and so on, okay? So I'll write them all out. 3 squared times 0.2 plus 4 squared times 0.1 plus 5 squared times 0.3. Okay, evaluate this. What will this give us? This will give us 11.6. But okay, but this isn't my variance. We need to do another calculation, and to work that out, the way to work that out is to do this e of x squared value here, so 11.6 minus my mu squared. Okay, so minus 3 squared. So 11.6 minus 9, we're just going to get 2.6. Okay, so that's e of x squared. So now we've got a mean, we've got a variance. We can use the Central Limit Theorem now, and we can obtain a distribution. Okay, and we know we can use the Central Limit Theorem because we've got a large n value here, over 50. You know, we've got a pretty large n of 80 here. So using the Central Limit Theorem now, how can we do this? Well, we can say x bar is distributed normally. Okay, remember it's going to be mu, and then my value here will be variance divided by n. Okay, so doing this now, what's this going to be? Well, we've worked out the mean, that was 3. My variance was 2.6, this will be 2.6 divided by n, which is 80. So we've got this now. Now we can actually do this. So this here, it's going to be the same, but with x bar. So x bar greater than 3.25. So now, just use your tables or your graphical calculator. Quite straightforward, just plug this into your graphical calculator, and what you'll obtain is that this is equal to 0.0828. And there we have it. We've worked out the probability that this mean will be greater than 3.25. And that's question 3 fully complete.